There is a correct order to learn AI engineering, and most people start at step 4. They jump straight into LangChain or vector databases, build a chatbot that sort of works, and then wonder why no company will hire them. The reason is simple. AI engineering is a dependency stack. Each skill builds on the one below it, like floors in a building. Skip a floor and the whole thing collapses. So let me walk you through the 5 skills in the exact order you should learn them, starting from the foundation. Skill number 1 is Python and software engineering fundamentals. This is the concrete slab your entire career sits on. Over 85% of AI engineer job postings on LinkedIn in 2025 list Python as a required skill, not optional, not preferred, required. But here is what people miss. Knowing Python syntax is not enough. You need to understand how to write clean functions, how to organize code into modules, how to use version control with Git, and how to write basic tests. Think of it this way. If Python is the language, software engineering is the grammar. You can know every word in English and still write sentences nobody can understand. Spend at least 4 to 6 weeks here before you touch anything related to AI. Learn data structures like lists, dictionaries, and sets. Get comfortable reading other people's code on GitHub. Write a small project, maybe a command line tool that pulls data from an API and saves it to a file. That alone puts you ahead of half the people calling themselves AI engineers. Skill number 2 is machine learning and deep learning literacy. Notice I said literacy, not mastery. You do not need a PhD. You need to understand what a model actually is, which is basically a mathematical function that learns patterns from data. You need to know the difference between training and inference, which is the difference between teaching the model and using the model. Get familiar with scikit-learn, which is a Python library for classic machine learning, things like classification and regression. Then move into PyTorch, which is the most popular framework for deep learning, the kind of AI that powers image recognition and language models. Build something small. Train a model that predicts house prices or classifies movie reviews as positive or negative. The point is not to become a researcher. The point is that when you later work with large language models, you will understand what is happening under the hood. You will know why a model hallucinates, why temperature settings matter, why fine-tuning works. Without this floor, you are just copying and pasting code you do not understand. Skill number 3 is LLM orchestration. This is where things get exciting and where the job market is absolutely on fire right now. LLM orchestration means connecting large language models like GPT-4 or Claude to real-world tools, data sources, and workflows. The key frameworks here are LangChain and LlamaIndex. Think of them as plumbing systems. The language model is the water, and these frameworks are the pipes that route it where you need it to go. You also need to understand function calling, which is a way to let the AI model trigger specific actions, like searching a database or sending an email, instead of just generating text. This is the fastest growing skill demand in AI engineering roles right now. But here is why the order matters. If you jump into LangChain without understanding Python well, you will drown in abstraction. If you jump in without understanding ML, you will not know how to debug when the model gives you garbage output. The dependency stack is real. Skill number 4 is vector databases and RAG architecture. RAG stands for Retrieval Augmented Generation. In plain words, it means giving an AI model access to your specific documents or data, so it can answer questions accurately instead of making things up. The way this works is you take your documents, convert them into numerical representations called embeddings, and store them in a special database designed for fast similarity search. That is a vector database. The big names are Pinecone, Weaviate, and Quadrant. When a user asks a question, the system searches the vector database for the most relevant chunks of information, then feeds those chunks to the language model along with the question. This is now table stakes for building production AI applications. Stripe, for example, uses RAG architecture to power internal tools that let their support team instantly search across thousands of pages of technical documentation. Build a RAG chatbot that answers questions about a PDF or a set of documents and put it on GitHub. That single project demonstrates skills 1 through 4 all at once. Skill number 5 is production deployment. This is the skill that converts a Jupyter notebook prototype into a shipped product that employers will actually pay for. You need to know Docker, which packages your application so it runs the same way on any computer. You need FastAPI, which is a Python framework for building API, essentially the door through which other software talks to your AI system. And you need CI/CD pipelines, which stands for continuous integration and continuous deployment, meaning automated systems that test and ship your code whenever you make a change. Without deployment skills, your projects live on your laptop and die there. Here is the common pitfall I see constantly. People collect certifications like trading cards and never build anything real. 2 to 3 end-to-end portfolio projects on GitHub, like a RAG chatbot or an AI agent workflow, are worth more than any certificate. Another pitfall is ignoring system design. Senior AI engineers need to architect multi-agent pipelines, manage token budgets so costs do not spiral, and handle evaluation and observability at scale. That means monitoring whether your AI system is actually giving good answers in production, not just hoping it works. The career path from junior to senior follows this same stack. Junior engineers operate at layers 1 through 3. Mid-level engineers own layers 4 and 5. Senior engineers design the entire system and make architectural decisions that affect cost, reliability, and accuracy. Start at the bottom. Build each floor solid. The people who do this are the ones getting hired, not the ones who watched a LangChain tutorial and updated their LinkedIn headline. If you want more roadmaps like this, you can find me at jprasad.com.